um, do some beautiful number that is called the number E. Um, and this is a constant number that is usable in many branch of science and mathematics. So the number E is a number that that has a number like this. So basically, it's an E. That's why it's called number E. So exponential. E is equal to 2.71828 and so forth. It goes forever. Okay, so basically, um, the bottom line with this is that it's a number that goes forever. It's an irrational number, right? It's a constant. It's used in mathematics and science and calculators. They got it. Even Excel has it. But anyway, so let's jump into it. So let's say, for example, that how this number was calculated, right? That will be the question. So the thing is like this, right? So let's say, for example, we have x, right? And x, let's say that x is going to be this value now. So, and then we have a, right? So we have a 1 plus 1 over n, right? And then to the nth power. So now, let's say, for example, when I calculate this number, right? So think about it. This number, 1 plus 1 over n, if n goes to infinity, this number is going to be a number that is almost equal to 0, right? But if it's multiplied by a bigger number, it will compensate. But it will approach a value, and this value is this. It's this value right here. Same thing. If the number that we enter here, in this case, is small, it's going to approach a certain value. Why? Because it's going to go to infinity smaller here, but it's going to be getting infinity smaller here. So infinity smaller to infinity smaller, this cannot equal 0. You cannot divide everything by its completed 0 right here. But what you can do is you multiply it by the exponent, and it's going to be equal very close to 1. So have you ever seen a decreasing function exponentially that starts at 1 and it goes down like this? Okay, so that's why, right? An increasing function, like let's say, for example, this is number e, it's going to stay like that. It's going to increasingly go for infinity, but it's going to be minor changes. You're not going to see the big difference once this curve flats out. Okay, that's what I'm trying to say analytically. Okay, so this is the formula for this. Well, one of them, I mean, that is, the 0 factorial. You can do a bunch of things. You can do, the Maclaurin theorem and all that stuff to calculate this number. But we will do this way because we want to make it simple to make it a C++ code, right? So the question will be how the number it look like, right? So maybe you guys wondering. Okay, so this is the number E. Okay, so that's number E right there. So number E is going to be equal to that number is equal to infinity. Right there, that guy. Right. So it never repeats itself. It might repeat the pattern, but never repeats the numbers. Like, it repeated single digit, but you can see right here, right? You know, you see 7182 and then 81 and 82 again, and it's, you know, it goes 84, 50, 59, 04, so forth, right? It is an irrational number. But anyway, so, right, that is enough. Let's jump into the program. So, okay, so let's get started. Okay, so, so we will, let me just that. So there's the formula, right? Now what we can do, we go to Visual Studio, and we will create a new project. In that new project, we will create a empty project. And next, and we can call this the famous E. Famous E num. Right. So we have a name for it. You can call it whatever you want. It doesn't really matter. Okay. So right here you can now right here we can add where we can add is a item, right? An item, and we select C++ and it's a CPP file, and we click add. Right now, right here is where we write our code, and we say, right, this program will calculate the number E, right? Then what we can do here, we can just put the directives, right? So it's an E, I'm sorry, so it's an include, right? And then we say include, and then we put this little thing like this, and then we say C, and then we do some mathematical operations. Then on the bottom of here, we said, okay, so include, and then include again, right? And then we said UO stream, right? And then over here we said using name, and then space, right? And then std, and then here we said main, int, right? Int, and then main, and then we put a set of quotation mark like this. I'm sorry, parenthesis, and then we put a like that, right? And then we put on the bottom over here, in this we will say return, right? Return, and then return 0, right? So it goes, we put that right there like that. Okay. So now, right here, we will declare, right? So we say declare objects, right? And then we do, and the reason why we're saying this is because we want to declare the object. C++ is an object-oriented programming language, so we have to make declarations. So let's declare number. Let's make it double. You can use float too. Why would say using double? Because the data type has a decimal on it, right? So double, and then we said n equal 0, and we say double e equal 0, and somebody can say, well, why you don't use n for n? Why you don't use integer? Well, I mean, then you have to do C++ is very tricky sometimes. It doesn't like when you combine integer data type and double data type, so you're not going to hurt anything anyway. So in this case, but anyway, so we got those right now. We right here we said cout. We want to prompt the user cout, and we do inside here. We said enter the value of n, right? So of n, and then we put right here in outline. That's the the last thing that would go to finish that line, right? So then we go, okay, so now we have that, right? So we had a cout, then we display that to the screen, right? But then we had to see in something to prompt the user. So we prompt the user, but now what? I need to, we need to put something so that the user, a placeholder, so the user can enter a number, right? So we said C in, right? And then we said, and then we use the brackets like this, and we put n, and then we just go, and that is a cin command, right? The cin line of code for prompting the user, right? Now, so now here I will do something like this for this specific problem. I will explain why. 4, and then right here the 4 gets normally 3 things over here. It gets a counter. In this case, our counter will be the e, and because we have to, unfortunately, we declare that e that is equal to to 0 on top, but we got to do the same thing with the for loop. And then we have to put that equal to 0 in there, and then right here we have to say that e, we have to do a comparison, right? So we comparison e to some value. So e is going to be equal, less or equal to n, right? And then put another semicolons in there, and then we do n plus plus, and this is not gonna work, right? This will not work, and I will explain why. But I'm just telling you that this will not work. But anyway, and I will explain why in a minute. Okay, but I'm doing this on purpose, so we'll fix it. We'll make it work. Anyway, so we got that, right? We got the for loop. Now what? We need some instruction to tell the program, okay, so if this is equal to this, but then what? Do something, right? Okay. So right here, I will say, okay, so if this is true, right? If this is true, then do something, right? If n has to be greater than 0, right? If n is greater than 0, then we put another set of brackets in there because we will do something here. So if n is greater than 0, then we will say, okay, so e is going to be equal to this formula, right? It's going to be equal to POW, which is power, POW OW in C++. And then inside right here, we'll put the formula, put the 1 plus, right? 1, right? Plus 1. And then we divide that one by, divided by n, like this. And then inside here, inside this bracket, I am putting the exponential, which is, I put a comma there, and I put the n, right? Because we'll do this operation first, this, and then after it does this operation, right here, it will take this n and exponentiate to that number. So whatever the value of n is, right? So that's the formula. Now we said, okay, if this is true, then do this, right? But then we have to see out something, right? So use this. And just change the value here and just we put another, and then we want to display E. But over here, I will have to change the number of, I will have to just modify this and insert the value of E is, right? And then we put is, and then right, like that, right? So now, but then what if that number is not greater than 0? Then if that number is not greater than 0, then we can display something else. We can say else we display another number, another statement inside this, and we said, okay, if that statement is not true, if n is not greater than 0, then we can say the number you entered is invalid, right? Okay, so we can say that, we can say right here, enter the value n, you can say greater than 0. Right. So now, if that is not true, then it will just display this. If the number is not greater than 0, right? But over here, I don't need to display that E. Right? I don't need to display that. Okay. So, okay, so let's say, for example, I want to run this program right now. And this is what I'm trying to explain to you, why this is not going to work if I do it this way. So E is going to be less or equal to number n, right? But in order for this to be equal, have to enter exactly the number of n has to be equal to the number of E. Well, then I have to probably just enter, 2.71, 828, right? And even like that, it probably will not work because, it will not be equal. But anyway, so that is not the point. The point is that we want to approximate the best approximation of E. So therefore, this number has to be bigger. If this number is bigger, then I still add 1, and this will go forever. It will never end. It will never end. Because this will be always greater than E. This number n will be always greater than E. In order for this to work, to calculate this value of E, number n has to be, in the thousands. But anyway, so it's going to be always greater than this. But anyway, so if I run this, it will run, but it will be an infinite loop. So, okay. Okay, so let's do 1,000. You just keep, you just keep looping. Just keep going forever, right? So to stop that, we do Control C and we kill it, right? Now, so it does the calculation, but it goes forever. So we don't want that. We want to stop it, right? We want to limit. Now, think about that. Now, in order to do this, instead of do n plus plus, which is going to increment n, I'm going to do the opposite. I need to decrement n. So it will calculate 2.71, A to A and so forth, but it will decrease it. It will decrease by 1 instead of increasing it. So that will do it, and minus minus, right? So now this is going to be, it's going to be less or equal to, and it's going to be decreasing, decreasing, decreasing until it's going to be less than E. It's going to be less than N eventually. So, okay. So let's see. Okay, so now let's try this again. And let's do 1,000 again. Right, here you go. Now you can see that the first value is very close to that, right? Now, if we increment this by a little more, it's going to calculate pretty close to that 7.7, 0.71, and so forth, right? So let's do this with another number, and let's do 100,000 now. 100,000 iterations. Now you understand. You will understand why it's a big difference between the computer and this phone, right? This is a telephone. It was made, and I know that you know this is a telephone. I am not trying to be smart over here, but it was made to talk, right? Telephone that what basically, yeah, sound from far distances, right? It takes a while, but it did the calculations. But the computer is made for number crunching. So the computer is multitasking device that does calculation. This one is technically punching with a microcontroller. It's not a computer. It doesn't have the power that the computer does. It doesn't matter what I 30, I don't know what's the highest speed right now. I mean, the highest phone right now. But you can have the highest 100, but it will never be like a computer because a computer is made to multitask, to multi-punching. This one, it's not gonna be able to do everything that a computer does. That's my opinion. But anyway, um, okay. So anyway, so it did it calculated, right? So now if we scroll up all the way up, you can see that it's very close. It's very close to that number, 71813. Now, if I put a closer number, a bigger number, let's try 150,000, right? It's going to be very close, very close. It will take a while though to do this. It's a bunch of iterations. But you can see the number very close. 26 is the last digit now. It's reducing down, it's 25. See that? It's 23. It is reducing down because it's going to be at 2.7 And that's when the number becomes a less, right? 2.37, right? Now, if we go all the way up to the first number, it's very close, right? It's very close. Mm-hmm. But still, I'm not seeing the 8 to 8 digits pretty close. Okay. So, so let's change this to float. That making okay. So let's run it again. Let's do 100. Okay. Okay, let's see. So it's running. It's taking a while, but at least we're getting 7-1 pretty close. Okay. So he did it. Let's. Oops. Okay. So very close. Right now. Let's do one more time, and that's it. Let's do. But you're getting the idea that it's getting very close. So right. So 200. Okay. So let's do it this way. So you can see that if that number goes to infinity, it will get close to that. But it's pretty close. So it takes a while to do all this bunch of calculations. It's 200,000 iterations. I will calculate that. So you can see that it's 7-1 right now. 7-1. It looked like 8. Okay. So you can see that it's 9-2 right now. 7-1, 9-2, right? So 7-1, 7. It's very close. So now let's try one more time. One more. That's basically just put a bigger number in there. So let's put 300,000. Let's do 500,000. But you see my point, right? If taking the numbers, decrementing it by 500,000 times. So now we're reducing it down. So it's taking a while. We can see the number right now changing. So So you see, like the computer is working. It's working a little harder, but eventually we'll do it all. So you can see, you might have to just double then. Maybe overflowing. I think it's over. Okay, now finally did it. Okay. So, okay, so you can see this very close, very, very close, right? So, um, okay, so it doesn't make too much difference whether we use the double or float, but so, okay, let's do it one more time, one last time. That's it. So let's enter 300,000 now. That's enough. Well, somehow it displayed it. It displayed the number somewhere, probably somewhere in there. So it seems like it's calculating. Okay, so now you can see, right? So this is a number, it's a special number that is called the number E. Pretty nice. It's decreasing. It's decreasing. So it's decreasing. So it's 27 now. It was 28. The last two digits. So, okay, so it's 26. It probably was 26 for 1,000 times. And then goes, at 25, you just keep dropping. 24. So it's getting, it's decreasing. You can see. Here you go. Okay, so up, all the way up. And at some point, some point is equal to, okay, so 718, right? And then 7181. So it's pretty close. Not bad. Not bad. Not bad at all. You can see, Pretty close. Pretty close. So I'm satisfied with this. Right? So I mean, it will take too long if I put more digits on it. It's going to probably take too much. But it's very close, right? Very close to that number. So we have a 718, right? 718. So 13 instead of 71828. Um. So okay. So that's it, guys. That's it for this video, and I will see you in the next video. Thank you.